An international team of astronomers using ESO's Very Large Telescope has measured the distance to the most remote galaxy so far. This is the first time that astronomers have been able to confirm that they're observing a galaxy as it was in the era of reionization, when the first generation of brilliant stars was making the young universe transparent and ending the cosmic dark ages. This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory, exploring the ultimate frontier with our host, Dr. J, aka Dr. Joe Liske.
Hello and welcome to the ESOcast. In this episode, we're going to find out how a team of astronomers used ESO's Very Large Telescope, the VLT, to confirm that a galaxy that had previously been spotted in images from the NASA ESA Hubble Space Telescope is in fact the most distant object that has ever been identified in the universe.
Studying these first galaxies is extremely difficult. They are very faint and small, and by the time their dim light gets to Earth, it falls mostly in the infrared part of the spectrum because it has been stretched by the expansion of the universe.
To make matters worse, at this very early time, less than 1 billion years after the Big Bang, the universe was not completely transparent. It was filled with hydrogen, which acted kind of like a fog and absorbed the ultraviolet radiation from the young galaxies. So, holding the record for having measured the redshift of the most distant object in the universe is not just a trophy to hang on the wall. It does have important astrophysical implications. This is the first time that we've managed to obtain spectroscopic observations of a galaxy from the era of reionization. In other words, from the time when the universe was still clearing out the hydrogen fog.
Despite the difficulties of finding these early galaxies, the new Wide Field Camera 3 on the NASA ESA Hubble Space Telescope discovered several very good candidate objects earlier in 2010. They were thought to be galaxies shining in the early universe at redshifts greater than 8, but confirming the distances to such faint and remote objects is an enormous challenge and can only reliably be done using spectroscopy from very large ground-based telescopes.
The team was excited to find that if you combine the huge light-collecting power of the VLT with the sensitivity of its infrared spectroscopic instrument Symphony, and if you then use a very long exposure time, you just might be able to detect the faint glow from one of these very remote objects, and then go on to measure its distance.
A 16-hour exposure with the VLT and Symphony of the galaxy UDF-YD381355339 did indeed show the very faint glow from hydrogen at a redshift of 8.6. which means that the light left the galaxy when the universe was only about 600 million years old. This is the most distant galaxy ever reliably confirmed.
One of the puzzling things about this discovery is that the ultraviolet radiation emitted by the galaxy doesn't actually seem to be strong enough to be able to clear out the hydrogen fog around the galaxy. So one possible explanation is that there must be other galaxies, probably fainter and less massive neighbors, that helped ionize the hydrogen in the region of space around the galaxy, thus making it transparent. Without this additional help, the brilliant light from the main galaxy would have been trapped in the surrounding hydrogen fog, and it could not have even started its 13 billion year journey towards Earth. Studying the era of reionization and the formation of the first galaxies is really pushing the capabilities of current telescopes and instruments to the limit. But this will be exactly the type of science that ESO's European Extremely Large Telescope will excel at. Once operational, this will be the largest optical and infrared telescope in the world. This is Dr. J signing off for the ESOcast. Join me again next time for another cosmic adventure.